Alright, continuing where we left off on example 3 for absolute value equations. I want you to look at example 3. It's a little bit different. The absolute value bars are only around x plus 3, and then you still have a plus 5 before the equal sign. In example 1 and 2, there was nothing else besides the absolute value bars on that side of the equal sign. So for example 3, before we split, you have to isolate the absolute value before you split. Or you split. And I will tell you, this is one of the most common mistakes that I see, is that we just split. And then that plus 5 gets all screwy. So move that 5, get rid of it, be done with it, and then split. So you don't want to split until the absolute value bars are all by themselves, and then we split, because you're only taking the absolute value of x plus 3, not plus 5. We don't want that messing things up. So we're going to move that 5 first. Then we still have our absolute value bars around the x plus 3. And now the problem looks more like example 1. So isolate before you split. Now that it's all by itself and there's nothing else around it, now we can split. So x plus 3 could equal negative 7, or x plus 3 could equal positive 7. Doing that will make sure you don't misuse that 5. So we're going to move that 3, x equals negative 10 for one answer, or we move the 3 and x could equal 4. And again, on your homework, it's going to have those curly brackets. You put the smaller number first, and then the bigger number. Curly bracket is called set notation. It is a set of answers. So I just kind of draw a squiggle. It's actually, let me draw it over here. It's technically a curve, a point, and a curve is what you're going to see. For some reason, that's very hard to draw, and so squiggling works. They're called curly brackets, a curve, a point, and a curve. That is called a curly bracket. You can write that down, curly bracket. I did not know those officially had that name, but that is what they are called. And a curly bracket is what we use for set notation. It's not a parentheses, it's not a square bracket. All right, so same idea for example 4. If you want to pause and try example 4 on your own, now would be a good time to do that, and then play back to see if you got it. Again, the absolute value bars are just right here. We're going to add 2 to both sides. So the absolute value of x plus 5 equals 14. Then we will split. So x plus 5 equals negative 14, or x plus 5 equals positive 14. Move that 5. X equals negative 19. Or move the 5. X equals positive 9. So 2 answers, one for the negative possibility, one for the positive possibility. All right, example 5 and 6. I don't like these. These require more work because of the bars on both sides. So let me kind of divide my space so I don't get too messy here. All right, so block this off. Try to maximize the paper space, but I don't want it to be too messy. Drawing lines between them can help. All right, so for these problems, when there's brackets on both sides, you still split. It's just more on both sides. It's not just a number. So we're going to say x plus 6 can equal the negative of 2x minus 3, or x plus 6 could equal the positive 2x minus 3. notice that the signs aren't changing. This is plus 6, it's still plus 6. Sometimes our brain switches those signs. This is plus 6, that's plus 6. What changes is the sign in front of the other expression. This is still 2x minus 3. This is still 2x minus 3. The only difference is this guy has a negative in front. So be careful with that. Your brain loves patterns and it loves trying to figure it out for itself. So sometimes it does some extra switching and you don't want it to do that. So we're going to distribute that negative. That's the only reason these are going to change. We have x plus 6 equals negative 2x plus 3, or x plus 6 equals 2x minus 3. We're going to solve these separately. However you want to solve them is fine. I'm not going to talk through all my steps here, so hopefully you'll be comfortable with solving and you can solve it however you want to, and talking through the steps might confuse you more, and I don't want to do that. So you should get x equals negative 1 for that first one. And then again, solve. You can do the same steps if you want to. You want to divide by negative 1 when you get to the bottom of this one, and it should be x equals positive 9. Make sure you guys can see that. Okay. So we still do negative and positive. It's just that negative applies to everything in there. All right, I would again pause and try example 6, and then I will go through it. So we're going to have 7x plus 12 could equal negative x minus 8, or 7x plus 12, sorry, it's lumpy here, plus 12 equals regular without the negative x minus 8. And we'll solve for x. On the negative one, you'll have to distribute, so 7x plus 12 equals negative x plus 8. Keep going with this one. I'm going to add x to both sides, and I'm going to subtract 12. You can do it at the same time if you want to. You should end up with 8x equals negative 4. So x equals negative 1/2 is one answer. And then I'll do the same steps. Subtract x and subtract 12. I add 12. Oh no, sorry. Losing track of things. Here we go. So that's going to become 6x equals negative 20. Divide by 6. X equals negative 20 over 6 is going to reduce to negative 10 over 3. Now in my math lab, I want to show you when you have a negative fraction for an answer in my lab, you want to put the negative, and then you want to choose the fraction box after you put the negative. So you want to put the negative, then you choose the fraction box, then you put your top number and your bottom number. But the negative is going to go out front and then choose the fraction box. That way it doesn't get, I always write it with the negative on top, but when you go to put your answer in my lab, that negative is technically out front. Alright, so that's absolute value equations. You split to the two possibilities and solve them separately. For the inequalities, anytime you have inequalities, a graph is involved. And these can be confusing. I'm going to try my best to keep it as simple as I can. We're going to focus on less than, and then we'll focus on greater than. So let's focus on less than first. Let me adjust my camera. Alright, so for less than, we're going to solve them like an equation, and less than is between. So your answer for less than is going to be the between. And then your greater than, I'm going to put it down here so it's not confusing, your greater than is away. So for away, they're going to be going in two different directions. For the between, they're going to be between each other. So between for less than, right, you want to be less than 5 miles from work, or away. Away is going to have two different answers. So let me just jump in here. I don't want to be more confusing than I intend to be. This is the absolute value of 2x plus 1 is less than 7. So we're going to solve it just like we would an equation. 2x plus 1 could be negative 7. 2x plus 1 could be positive 7. I think this is the same one we solved on the previous page. So I'm going to save time, I'm just going to write the answers. X could be negative 4, or x could be positive 3. So we're going to put negative 4 on the graph, positive 3 on the graph, and go between them. So we're going to draw a line between. So less than is between. It does not have a bracket, so both sides are going to get parentheses. If it had, a line. If it has a line underneath, you put brackets. If it does not have a line, you put parentheses. So your graph looks like that. Your inequality is that negative 4 is less than x is less than 3. Again, we read that x is between negative 4 and positive 3. And the interval notation will look like that, just like it is on the graph. Negative 4 to positive 3. So again, we're going to solve it like an equation, just like we did on the previous page. 5x plus 2 could equal negative 10. 5x plus 2 could equal positive 10. To save time, I'm going to solve for x. X could equal negative 12 over 5. X could equal 8 over 5. So we're going to throw those on the number line. Negative 12 over 5. 8 over 5. Less than is between. So we're going to go between. And then brackets on both sides this time. So the interval is negative 12 over 5 is less than x is less than or equal to, less than or equal to x, less than or equal to 8 over 5. So you solve for x for negative, solve for x for positive, put those values on the number line, less than goes between, and that's how you write your interval and your inequality. So interval is bracket negative 12 over 5 to 8 over 5. And do less than one more time. You're going to split this. Negative 5x plus 3 could equal negative 12. Negative 5x plus 3 could equal positive 12. To save time, I'm going to go ahead and solve x equals 3, or x equals negative 9 over 5. You put those two on the number line. I think I did that. Oh, no, I didn't, because the coefficient's negative. So you're still going to put negative 9 over 5 on the left and 3 on the right. It doesn't matter where they came from. It just matters where they are in relation to each other. Then you're going to go between, and this time it gets parentheses. So negative 9 over 5 is less than x is less than 3. Again, we say that x is between negative 9 over 5 and 3. And the interval is the same, negative, I did bracket, my bad, parentheses. Negative 9 over 5 and 3 with parentheses. So if you can remember, less than is between or within, right? Within is another word that might make sense. Within 5 miles, within 4 miles, between two things. So it's always between for less than. Greater than is away from, right? When I taught high school, I did not want to grocery shop with my students. I wanted to be away from work. So that's opposite directions. So we're still going to solve this like an equation. I'm going to move that 5 out of the way before I start. You have the absolute value of x plus 3 is greater than or equal to 7. That means that x plus 3 could equal negative 7, or x plus 3 could equal positive 7. That means x could equal negative 10, or x could equal 4. We're just going to put those on the graph, negative 10 and 4, and because it's greater than, it goes away. So away and away. They face away from each other. And they're both going to get a bracket. That means the inequality is in two parts, and so is the interval. So the inequality is going to go negative infinity to negative 10. That's the first part, right? That's the part on the left. There's negative infinity. And then the second part, so the or to infinity, there's a space between them. There's a space away from the middle. So it's negative infinity to negative 10 or 4 to infinity. The interval looks very similar. Oh, sorry, that was the interval. I'm so sorry. That is interval notation. The inequality would be x is less than or equal to negative 10 or x is greater than or equal to 4. I'm so sorry about getting that mixed up. This is the inequality, and that's the interval. For or, we're going to use the U symbol. U stands for union, and that's the symbol we use for or. So if you see that, instead of the word or, that's the symbol you're going to use. Let me try that again on the second one, so not get it mixed up here. So again, we're going to solve it separately. R plus 5 could equal negative 20, or R plus 5 could equal positive 20. That means that R could be negative 25, or R could be positive 15. We're going to put negative 25 on there, put 15 on there, again relative to each other, negative on the left, positive on the right, and they're going to go away from each other. So away and away. And it's going to be parentheses. So the inequality is going to be x is less than negative 25, or x is greater than 15. You have to read that from the graph. X is less than negative 25 or greater than 15. So for the interval, it's going to go negative infinity to negative 25. You'll see the U for union, and then 15 to infinity. It's usually all on one line. I just ran myself out of room. All right, so last but not least, again, we're going to solve this like an equation, graph it, and draw the arrows away from each other. So this is negative 2x minus 4 could be negative 5, or negative 2x minus 4 could be positive 5. And if it helps to write the word or, I do recommend it. Sorry, my R doesn't look like an R. Here we go. All right, so we're going to solve for x on each one. I'm going to do that work for you. X equals 1/2. I do recommend pausing the video, solving it yourself, making sure you still got 1/2. And then x equals negative 9/2. With those two answers, we're going to put the smaller number on the left, the bigger number on the right. Negative on the left, positive on the right, however you need to think about it. It is greater than, so it's going to go away from each other. And it has the line underneath, so we're going to put brackets. So the inequality is that x is going to be less than or equal to negative 9/2, or x is going to be greater than or equal to the positive or the bigger number. For the interval, it's going to go negative infinity to negative 9/2 with a bracket. And you're going to have the U for union, another bracket, 1/2 to infinity. Remember, infinities always get parentheses, and you determine bracket or parentheses on the value by the inequality symbol. All right, so absolute value inequalities, the book does explain it a little bit different for how to solve it, but I have found this technique a little bit faster. Solve it like an equation, put the equation on the graph, put the two answers you got from the equation on the graph, go between for less than, and go away for greater than. And I have found that to be a little easier to follow. All right, so that's solving equations, solving inequalities, solving absolute value equations, and absolute value inequalities. That is all of your homework one. It is a little bit longer because a lot of it is review from before college algebra.